the channel. So today we are solving Leetcode 2537 lead code question, and that is a count the number of good subarrays. So today we are solving this question, and it's a medium level question, and it's related to sliding window problem. So if you're not aware with, you can just search sliding window, you can understand the tricks. Okay, and I have also added a couple of videos of sliding window the problem. If you don't know, then I will add some more videos, and from where you can learn. Okay, so let me know if you don't know. I'll ping the sliding window problems related to it, and you will go through that. Okay, so it's a medium level problem, guys, and it's a sliding window problem, and we will not just solve it deeply to understand the intuition behind it, but we will go through the step-by-step problems solving. Okay, so the question we have 2537 is saying that we have given an integer array nums and an integer k, that we have to return the number of good subarrays of nums, and a subarray array is a good if there are at least k pair of indices ij such that I is less than j and array at I is equal to array at j. So a subarray is a contiguous non-empty sequence of elements within an array. Okay, so if you go through, if you can pause this video, or if you'll go through these examples, so you will understand the explanation what is trying to say. Okay, so let's pause for 1 second and go through it. So let's first understand what's the question is asking. Okay, I think you have gone through the statement. So the problem statement is saying you are given an array of integers nums and an integer k. As you can see here, means we have given two things, integer array and nums. Nums as a name as array, and k is a integer number. Now it is also saying you need to count the number of sub arrays, right? We have to return the number of good sub arrays of nums, means you need to count the number of sub arrays that such that there are at least k pairs of ij will be there, means it should be ij and I should be less than j, but the elements should be also equal to each other, right? Means nums at I, the elements at I, or you can say array at I, should be equal to these elements. Okay, so it is a little confusing because here it is saying nums and here it is saying array, means because this is a num is a array, but this is a sub array nums, right? Means whatever the sub array you will find, there will be two pairs will be there, right? And it should be like this condition and it should be like this condition. Okay, means we have given an array of integers that is called nums, and we need to count the number of subarrays like this, and at least there should be k pairs of indices, means number of k is given, that number of pairs should be in the subarrays, right? And this is the condition should be there. I think you understand, right? So the key definitions will be a pair means two equal numbers with the different positions. A subarray is a contiguous part of array, and our job is to find how many subarrays have at least k such pairs. Like for example, if you go through this example, right? So you can see we have given a array, right? And there is a k, we have 10, right? So how many outputs are there? So there will be only one subarray is array itself having, right? Then if this is the array and this is k equal to 2, then how many subarrays are there, right? So first of all, there are 4 different subarray groups are there, right? And if you'll go through these are the pairs we have, right? So it is easy to find subarrays in this example, but it's difficult to say that what are the subarrays are there, right? Because the only good subarray is the array nums itself, but right, because only the full array has 10 equal pairs, right? 10 equal pairs here. So if you'll find the 10 equal pairs, means only the full array has 10 equal pairs, right? And so it was 1, but in this case we have k is 2, and so if you can see here, there is 2 pair is there, there is also 2 pairs there, between that these 2 pairs are there. So there are 4 different subgroups that contains 2 different pairs. If we'll go through the I and j, the elements are same, right? Means 2 elements should be duplicate in this subarray continuously, but the array's index would be contiguous, right? So this is the statement it's saying. So you can go through, you can pause this video now. I can go through again for this count to understand the intuition, because see, if you not understand the intuition, you cannot build the intuition, right? And so let's try to understand the statement. Give me 1 second. Okay guys, so these are the steps I have already mentioned here. Let's now try to build the some intuitions, because the brute force would be try all the sub arrays and will count pairs in each, right? So there will be O of n square, because see, if you are going to find the sub array, obviously you have to go through the brute force approach, right? And you will have to try all the sub arrays, and the count in each pair will become that count, okay? But the time complexity will become O of n square, because it's too slow for the 10 to the power, I think how many, 5, right? As you can see, the length could be higher, right? So the constant we have given, and so it's too slow for n up to 10 to the power 5, right? So that is why if we'll go to the brute force approach, then you can find the subarray. We can try all the subarrays, right? That is fine. But problem is that it will become O of n square, and that is too slow for n number of elements that we have given, length of array. And so we should use sliding window approach. That is why I told, if you are aware with this sliding window approach, that's fine. If you not, it's also fine. If you don't know, let me know. I'll put the comment of my videos, or you can go through the Google or anywhere, and you can find the sliding window approach, how to do that. So sliding window approach is, there should be 2 index should be there. It should slide such a way that we can have a pair of elements as a subarray, okay? And that we will do in the program. You will understand that. So our key observation is that when we expand the window by adding a number, if number already exists in the window, it can form a new pair, right? So every time we can see a number x that already appear in let's suppose f times, it creates a f new pairs. Let's suppose x pair is there, then it will create x pairs. F pair is f pair, right? So our goal is to maintain a running count of total pairs in the window. So we will expand the window to the right, and as soon as the window has at least k pairs, we all know all subarray ending at a right and starting anywhere from the left to right are valid. When we shrink the window from left to right, we'll try all the subarrays, okay? So what we will do, we'll go through the step by step, so you will understand easily, right? So first of all, let's now go to the code and let's walk through the step by step, so you will understand. So first of all, what we will do here, we'll create a map of integer, so we can have the frequency to count the frequencies of the elements, right? And we'll create a 2-pointer algorithm, because this is a 2-pointer algorithm like a sliding window. So 2 pointers will take left and right for the window boundaries. Then we'll take pairs. We will also have pairs, right? So this pair will take a number of equal index pair in the window, and finally we'll have the result. So this result will return as a count. You can say result as a long count, you can say, and we'll return the count as a number of good subarrays, you can say, that contains these qualities, you can say, okay? So let's iterate through the array with the right pointer. So we'll create a right pointer. We'll start from the 0, and we'll keep moving ahead. We will find the pairs, right? So what we are trying to do here, we'll first create a loop, for loop for each element, that is called current element. We'll update the frequency and the pair count. So if the current has a pair count times before, it can form count new pairs, okay? So let's suppose by default we'll take a frequency. If the frequency of this current element is not there in the frequency map, then it will be 0, count will be 0. And if it is something like this already appear, means count frequency will become 2, okay? Means it will get incremented each time, right? So next time we'll increment the frequency of the current number. So what we will do, we'll update the frequency like this. So you have the count now, will increase the count by 1, right? Once you will find it, so your frequency will get updated. So now shrink the window from the left side with the pair if greater than equal to k. So all subarray from the left to right are good, so we can count them. How? So we'll check the condition. If pair is greater than equal to k, so we will have all the count, right? We will count the subarray starting from the left to right, and to do that, what we have to do, nums length minus right will do, we'll get the result plus plus. Okay, finally what we will do, we'll remove the leftmost element from the window. Like we'll take a nums at left, we'll get the left value, and the frequency count we'll get the frequency count. We'll remove one stance of left val, reduce, we'll do count minus one pair, then we'll do, so one pair will get reduced from here. Then we will add again, we will update that element, because that we have removed that, so we have to remove the count also, we have to update the count also. Okay, and then we'll get we will move the left pointer, so we'll keep moving ahead, right? We will move the left pointer forward, it will keep forwarding ahead, and then you will return the result, right? So what we are trying to do here, so first of all, when we add right window, means we will count how many times it has appeared before that many new pair added. So we will go with this piece of code, means we will we add nums at right, nums at right, and we count how many times it has been appeared before that how many new pairs were added. Like that we will do. As long as we have at least k pairs, we can count all the valid subarray ending at right, and then we will sync the window to find the smaller one, and then we'll keep updating the frequency at each time, and then we'll keep moving ahead, right? So now what you can do, you can take an example of any of these problem statement, and you can do you can retry quickly, dry run quickly, and then you will see how the window grows until the pairs having greater than equal to k. At that point, we'll go through the left to right, all are valid subarray. When we will add n-1 result to add, then we will move to the left to try shorter subarray. Then you will get the final output, and then we'll get the everything there. Okay, so it's very easy problem. You can just pause this video, and if you go through the steps, you will understand clearly. So just try by yourself first. Okay, and if you talk about the complexity, you can see we are going for all the elements, and so for the all elements we are, means each element we are entering and existing from the window. So it will take O of n square, no, so O of n, not a square, O of n times number of element times space complexity will become O of n, because we are storing all the elements here in the map, and so has a stored frequency of elements. As you can see, we are storing as here also and here also, so each time we are storing the elements. And that's all in this video. We have successfully solved this Leetcode problem with a clean O of n solution using the sliding window and hash map. So if you learned something new, smash the like button guys, and drop a comment if you want a breakdown of other sliding window problems, and don't forget to subscribe for more. Thank you for watching this video.